in tomorrow, you get less points because they're late. But I don't want you working on it now. What's that? Well, you can turn them in if you have them done. But if you don't have it done, I want you to finish it. So, E3, we're going to make and analyze box and whisker plots. So I think you guys have done, you did stem and leaves, and maybe you've seen the dot plots before. So, if we think about our standards are, I can choose the best representation, a dot plot, histogram, or box plot for a set of data. I can decide which ones preserve the data. We talked about yesterday that our histograms often do not preserve the data, right? You can't tell how many of a certain one. Where in a dot plot you can, and you also can when you make that stem and leaf plot. That kind of preserves it. A box plot, you're going to be asked to calculate the 5-number summary. So this is really important that you know first what is a 5-number summary. So yesterday we talked about some of our data things. The 5-number summary are these 5 data points that you need. You need the minimum. You will need the maximum. You will need the median. And then we break it down into a couple other medians. And they call it the quartiles, because we're breaking it into fourths. So when we look at that, we'll look at it as median 1, which is also going to be referred to as the first quartile. Okay, so when we think of that, that's our first quartile. And when we start doing these, and then you're going to have your median 3, which is going to be referred to as the third quartile. Well, the word quartile has to deal with anyone in Latin. Latin always seems to know quartile, or if you're just thinking quart divides it into what? Fourths. Quartile, fourths. So this is dividing it into 4 regions, okay? And I want you to look at these. These are some examples of a box and whisker plot, okay? The 5-number summaries. This number right here, please put down as our minimum. This number is called our quartile 1, okay? So when I said that first median is the first quartile, this is our exact median. That's the middle number. This is another median, and it's referred to as our quartile 3. And then this is our maximum. And anytime you have a box and whisker plot, you have those 5 numbers, thus the 5-number summary, making sure you know how to construct and plot the 5-number summary. The first number is always your minimum of your data, right? So this is always our smallest number. It's the minimum. The top number for this data in Class B's arm span, this was their maximum. When we find them, these two are really easy when you look at your data. This one is also pretty easy. It is your exact median. We talked yesterday about all the statistics, mean, median, mode, range. This is simply the middle of your data, right? Middle of your data. And then, if this is half the data, 50% of it, what quartile 1 is, it's just half of the bottom half. That's all it means. Quartile 1 means that, and you'll see as we go to this next page, this is quartile 1, and this number here is going to be our quartile 3. It just means that it's dividing our data. If you take a look at that next one down, it divides our data into 25%. So when you look at a box and whisker, it summarizes our data to display along a number line. It consists of 3 parts. The box. Inside that box is 50% of your data always, right? So please write 25 and 25 as you're filling that in your notes, right? This whisker over here has 25% of my data, as does this whisker. It has 25%. So the data is simply broken into fourths. So it says the left whisker extends from the minimum to the first quartile. That is 25% of our data. The box extends from the first to the third. So once I find those 2 quartiles, I put a box around it, a rectangular box. 50% of my data is in that range. And this is what's called, too, you'll see in your homework, find the interquartile range. Instead of just finding the range like we did before, taking our maximum minusing our minimum, interquartile means between these two numbers, that's 50% of our data. And then again, we have another 25% going up. So, first thing we're going to do, calculate the 5-number summary from our data. Then you will draw a number line with the appropriate scale. So, you'll put your numbers on it. You will never put this box and whisker right on top of the number line. It'll either be above it or below it. You will put the 5 dots for where your 5-number summaries are. Then you'll draw the box around quartile 1 to quartile 3. You'll put a line down the middle, and you'll extend from the box out to your minimum and maximum. So let's try it. First thing you are asked to do, we arrange our data. You need to find our minimum. So arrange the data. The easiest thing when you get your data, first thing they're going to do is arrange it from smallest to largest, okay? Least to greatest. Once you've arranged it from least to greatest, you can then pretty easily see our minimum, 75. Our maximum, 350. The middle of this data happens to be between 126 and 135, right? What do we do if it's between two numbers? We have to find the average of those two, okay? So halfway between 126 and 135, that's going to be my median, the exact middle. Now, if there were an odd number of numbers, it's that exact middle number. This had an even number, right? So we take 126 plus 135, add that first before you hit division by 2, right? If you put in your calculator 126 plus 135 divided by 2, it does not come out to this. Because your calculator thinks you only want to divide the 135 by 2. So when you put this in your calculator, please make sure you think of 126 plus 135. You get that answer and then divide it by 2. If you just put it in like this, it will not give you 130.5. Okay? Because your calculator always follows order of operation. Even if you think you're following it, and you just put 126 plus 135 divided by 2 without a parenthesis, it thinks do division before you add. So make sure you get this answer and then division by 2. Once you found that, this is the bottom half of our data. To find the first quartile, you got to find the middle of that. Well, the middle here is between 80 and 125. So you'd add 80 and 125 and divide it by 2. To find the third quartile, it's the middle of the top half. That's all it means. It's just finding another median of a smaller group of data. This median between 140 and 140, do you think we really need to add 140 and 140 divided by 2? That's kind of a waste of your time. It's simply 140, okay? So when we look at this, we have this 5-number summary. We have our minimum. We have, so this is our minimum, right? This is quartile 1. This is our median. This is our quartile 3. And this is our max. I want you to make this number line in that space down below, and we want to graph this data. Okay? So make a number line, and in that white space there, right up here. I know, do this one. Don't go on to the next problem yet. Make this number line go from 0 to 50 all the way up to 400, right? And do we really need the 0 to 50? Probably not. Because what was our first data point? 75. So we're going to put a point at 75. Right? Halfway between 50 and 100. 102.5, a little over 100. Next dot. That's my quartile 1. 130.5. Maybe about right here, right? 140. Still less than 150, right? And then 350. Anyone know what 350 is called? Special kind of number? Because it's way away from our data. So what you do next is you put a box around quartile 1 to quartile 3, right? This is quartile 1, this was quartile 3. Okay? You put a box around those two. Okay? You then put a vertical line in your median. This is our median. Just put a vertical line through that dot. You then extend the whiskers from quartile 1 down to your minimum, quartile 3 up to your maximum. This does have a really special number. When we look at that data, that is a very special number in mathematics. This totally affected ours, right? This 350, and if we look at our data up here, and we don't even know what we were looking at for our data. We don't know what kind of data, but that 350 seems really odd. This 350 is called an outlier. This, when we look at our data and statistics, is an outlier. There's a super cool book on outliers written by Malcolm Gladwell, if you ever have a chance. It's super cool. It's like why people succeed at different grade levels and careers. And so like some of you in sports, depending on your age and when the cutoff there are and ages, super cool book called Outliers. So, but this one is a definite, doesn't fit the norm of the rest of our data, right? Okay. So, yes, we are going to do this one now. Put the numbers in order from least to greatest. So you're going to start with writing down your numbers from the smallest. So we got 4, 8, 9, right? Put them in order from least to greatest first. So 4, 8, 9, 10. Did you have 14, 15, 16, another 16, 25, and 34. Okay? So, if we're going to list over here, the minimum is 4. Maximum, pretty easy to find also, right? 34. Median, our exact middle. So, if we are looking at our data, how many data points did we have for this? How many data points? 10. So, if we are looking at the exact middle, median, we have to go between 14 and 15, right? 5 numbers below, 5 numbers above. The exact middle of 14 and 15, what you're really doing is adding 14 and 15, right? And dividing by 2, which is 14.5. Okay. When the numbers are further apart, you may want to actually do that. You probably don't need to add 14, 15 divided by 2. You know 14 and a half is the middle. Okay. We are now going to find quartile 1. I'm going to take this lower data, and I'm not including this number here, right? So these 5 numbers and the exact middle, oh, I love it when there's an odd number. 9. The upper one, quartile 3, again, I'm taking my top data points, which I'm looking at the top half, 15 to 34, and the exact middle is 16. Quartile 3 equals 16. So, I gave you a number line. My hint would be go by 5s up to 40 so that you can get all of yours. And please make your box and whisker plot. Try it. Check with each other as you're doing it. Make sure you're plotting yours. And then the next part that we're going to look at is how do you interpret this? What does this tell us? So first thing you're going to do when you make your box and whisker plot, put your 5 points down. Box around the middle 3, vertical line, whiskers going out. Okay. Next page is your summary. You are making one more on the top of the next page. Okay. Construct it. These are various size, if we are looking at it, of various sizes of megabytes. So, put them in order. Start with that part. You should be able, before we go to lunch, to find your minimum and maximum. a nice group of numbers, right? At middle, right? Yep.
No, in like the second list, it's missing.
Oh, what do I not have? 194, thank you.
And 84. Yeah.
And 84. Yes. And I think I had those in mine, and they didn't have them in there.
Oh yeah, those are the 5.
Oh.
That's what it is.
Okay. So these are the 5 numbers, right? This is your minimum. This was your max. This was, when you put your numbers in order, this was the exact middle. This was your quartile 1 and quartile 3. So the first couple questions in your homework will ask you when you're doing on page 750. It will simply say, tell the 5-number summary. Questions like 8, 9, 10, something like that. Tell the 5-number summary. The next ones will say, tell the 5-number summary and make a box and whisker clock. So in this one, we are now asked, after we got our 5 numbers, we now want to construct this. So, somehow, talking about what we're looking at, if they had a title, that's a good idea to put that. We're talking about full-size megabytes. 25% of our data went from 54, if we are looking at this, or from 48 to 54, right? That's 25% of my data is right here, okay? The other 25% goes from 54 up to 100. That means however many numbers I have, 25% of them are in this range. Then going from 100 up to 188, we have another 25% of our data. And then if we were looking at the original problem, this is the last 25% of my data, okay? So if I'd ask you, where's 50% of your data? 50% of it, you could break that down and say, oh, from 100 down to 48 is 50% of my data, right? 50% of my data also goes from 100 up to 256, right? Because these two together make 50%. And this interquartile, from quartile 1 to quartile 3, is also 50% of my data. So what box and whisker plots do is another way of summarizing our data. We don't get to see individual points, but it helps us to break down and interpret data, okay? So, as you take a look at this last part of your notes, they already have the box and whisker plot made for you. This is looking at the average monthly rainfall in inches. They looked at Miami, Florida, and then they looked at New Orleans. You need to go back?
Yeah.
Okay, I will in just a minute. We're going to finish this one, then I'll go back. It asks you to compare and contrast the data from the 2 cities and be detailed. So, if we are looking at this, what could we say about their medians? The median of New Orleans is what? They're both what? Yeah, so we would say that, like, if we were looking at, does it look like, so this is half of my data is here and half of it's here. Same thing here. This is half. So if we want to look at that, we want to think of some statements that we're going to make. So I'm going to give you kind of an idea if we're starting out. This is kind of a sample. We might say something like, the median amount of rain in both cities is similar. We had here, what, about 5 point in New Orleans, or maybe less than 5.5. Here, about 4.75 inches. Is 4.75, if we're looking at Miami, if we're thinking about rain, is 4.75 inches of rain and 5.4 inches of rain in New Orleans. Is that pretty similar as far as rain total goes in those cities? It's pretty similar. Could you say New Orleans medium rainfall in inches per month is more than Miami, Florida, that'd be another statement, right? So looking at these, you want to think of as many different ways that you can write it. We now want to also look at different ways that they are different. And again, you're going to see one up here, and I don't know that this is the best one, but it's one of the examples that they have. Miami has a much larger range of rainfall, right? We agree. It goes from, in a month, from about 3/4 of an inch up to 8.5 inches in a month, okay? Whereas New Orleans range is much smaller. And what do you notice about New Orleans, if you look at this, is that when you're looking at New Orleans, look at where all of it fits within the 50% of Miami, right? 50% of Miami's rainfall each month, how much they get varying every month out of the 12 months of the year. New Orleans is always kind of within that 50%, right? So the middle 50% of Miami's is larger than 100% of New Orleans, right? What else could we say? We could say that something about New Orleans that if we are talking about like comparing these two, we, again, if you're thinking 25% in terms of months, right? So 12 months in a year, this means how many months are we talking about down here if it's a quarter? How many months are we talking about in each quarter? We're talking about in each month, right? So if we're looking at this, 3 months is equal to 25% of our data, right? So this is kind of telling us that 3 months out of the year in Miami, right? Because this is 25%, 3 months we get between 0.75 and 2 point something. 3 months of the year in Miami, you're going to get on average rainfall somewhere between 2 point whatever up to 4.3. 3 months, you're going to have from 4.5 up to about a little over 7 inches of rain. And for 3 months in Miami, Florida, they are getting, when do you think these 3 months are? What would affect this getting so much in Miami? What's the kind of weather that happens in Miami? Hurricanes, right? They might get tropical storms more than maybe New Orleans. So is that going to affect it? In years that they have more storms, would this change quite a bit? Yeah, okay. So just looking at your data. I'm going to go back to that last one.